Hello everyone, good morning, good afternoon, good evening, and thanks for joining us for our first Campfire of 2016. We're starting 2016 with the all-important topic of security, and specifically database security. Not a day goes by when you do not hear about hackers stealing data from companies, governments, and individuals, and it is fair to say that security is high on the minds of anyone managing IT assets, and if it is not, it should be. Today's topic today we will be covering database encryption. Oracle and Microsoft spend a lot of money to provide features that protect data stored in their databases. However, smaller companies and developers deploying their applications with SQL databases do not often go beyond user ID password as the security. And today what we will show you is that you can do a lot with databases without spending too much time, and with just a few techniques you'll be able to get a basic minimal database security in place. Oliver will take over for now and start the presentation.
Hi everybody. So as Riaz mentioned, we're going to get into database encryption and a couple other topics along the way that are related to it. So let's just dig right in. The first thing that we want to deal with right off the bat is what exactly is the purpose of encrypting databases? And this may seem like a stupid question or an obvious question, but it's something that many people get the answer wrong on. Commonly we'll hear that encryption is to protect the database from being stolen, or it's to keep out would-be hackers, or to prevent unauthorized users from seeing data that they shouldn't. And in fact, none of these answers exactly are wrong, but none of them are right either. So what is the purpose of encrypting your database? Well, it has nothing to do with the interface. It's about the files. The answer is actually quite simple. The purpose of database encryption is to prevent operating system users from bypassing the database interface and reading sensitive information directly from the storage system. These database files could be stored on external media in the form of a backup, or read directly off the host file system if the user has access to it. That's it. That's all encryption does, is it protects that one scenario. So we're done now. Thank you for coming. Well, actually, maybe stick around a bit and we'll talk about a few more areas that might concern you and your business that are related to encryption, and kind of show you some of the other techniques that are involved here. So the type of encryption that I was referring to there is often called transparent database encryption, transparent data encryption, or whole database encryption. And it's a good method for protecting data at rest, and this is an IT term that's used to refer to data that is being stored physically in a digital form. So it's not referring to the data that is in memory. So for instance, when you're doing a query, there are pages read off of the disk and stored in memory to execute your query. Those in-memory structures are not encrypted in a transparent data encryption environment. Only what is stored on the disk, the pages of data stored on the disk, are encrypted. Encrypting data at rest, reduces the risk of potential loss from a data breach. Whether that's someone walking out your front door with a USB stick containing your database, or whether it's someone that's penetrating your defenses online and remotely downloading your data. There are many things that it can't do, though. And so there are some scenarios we want to talk about specifically. Right off the bat, TDE, and in fact encryption in general, is not a be-all end-all of security. There are many areas that it leaves wide open. For instance, TDE does not encrypt the data flowing over your network. If you had, for instance, a computer on your network that had a network card running in promiscuous mode, or a poorly configured switch that was broadcasting packets from other connections out over the network, all of these are very common misconfigurations to see. it would be very easy to intercept all of the traffic occurring between a database client and a database server, and you would see all of this data in plain text form. Of course, there would be some structural data around it and those sorts of things, but it would not be encrypted. This, of course, doesn't even get into the over-the-air risks that are associated with Wi-Fi. So it's not just the copper or fiber within your building. If you have Wi-Fi access, of course, you may be broadcasting all of your data in plain text form as well, just over the air using your Wi-Fi network. Additionally, transparent data encryption or whole database encryption doesn't provide for separation of duties. Your database administrators still are going to have unfettered access to all of your data, nor does it allow for just certain users to have access to data. If you're authenticated, you have access to the data. It also doesn't deal with a situation where only some small piece of data needs to be encrypted or have limited access to it. All of these are areas that we're going to discuss, but they're not areas for which transparent data encryption is the solution. As I mentioned here, there's a couple other things to be aware of when you're using encryption. Right off the bat, obfuscation is not a form of encryption. So anything that you're doing to alter your data in some way, if it's a non-destructive alteration of your data, that's going to provide very little protection in this day and age. Another area that we commonly see is related to passwords. In general, it's best not to encrypt passwords at all because you don't want to be storing people's passwords if you can avoid it. And we've had a whole another presentation about securing passwords using hash algorithms that you can see on our YouTube channel. And that's really the solution you want to use there. So it's not a good solution for passwords. Another important thing to remember is that encryption, although many times you may have PII, personally identifiable information or confidential information on your system, it's best if you can find a way not to have to store that at all. Now that's unrealistic in many cases, and you are going to have PII in your database application. Minimizing the amount is really the best solution to take rather than dealing with the encryption aspect of things. Because of the fact that so many systems have PII, though, encryption ends up being a good solution there. So when should you use TDE? Well, you should use it when you're required by a regulatory body to do so. So in the United States, we have quite a few different regulations that may affect your business depending on what business you're in, from PCI compliance, which relates to credit card information most of the time. We have GLBA, Sarbanes-Oxley, HIPAA compliance if you're dealing with medical data. The SOC stuff is and GLBA tend to fall on public corporations, moreover. We have FDA Title 21, and then something that has proved quite viral recently is California Senate Bill 1386, which has required encryption for personal information at almost any level. So very often businesses will be affected by one of these compliance regulations, and throughout the world we have various ones. In Europe they have EuroSOX, they have the BDSG in Germany. There's just a wide variety for them, and some of these go back a long way, so many of you may be dealing with some of these things already. For instance, in the UK, the DPA was originally a regulatory compliance standard that was issued in 1984, so as long as we've been doing this stuff, there's been some security requirements around. If you're storing customer information, most likely that means you have some form of PII, which can be used for identity theft. And there's another case to consider as well. A lot of times your database of contacts or customers or leads may have competitive value that would drive you to use TDE. In all of these cases, encrypted databases deal with the risk associated with someone stealing the physical files that contain the data. And remember, from the standpoint of theft, there are many ways to go about it. Some of these methods don't even really involve technology. One of the most common methods that data is stolen nowadays is by means of social engineering, where someone literally just convinces one of your employees or a user to give them the data. And it's an insidious method of acquiring data, very simple, very low tech to acquire data by means of social engineering. Also remember that software stacks are constantly being patched against remote exploits. It brings up the question as to how diligent your IS staff is in keeping up with the latest CVEs and applying patches across a broad range of hardware used in your business. Are they doing that? Are they keeping up to date with patching your Wi-Fi hotspots, with patching your network switches, operating system software, remote access software? There's so many levels nowadays to deal with. TDE provides at least some level of protection so that if they are able to get in by means of some other method, at least that data at rest, which is normally what they get first access to, is encrypted. So something to think about there. TDE also has other advantages. It's the simplest to implement right off the bat. Just in general, a few commands entered in the database depending on which database system you're using, and it's done. The reason it's called transparent data encryption is because it requires no changes to your application. So that makes it something that you can do without having to worry about it impacting your application stack at all. Also, there's a negligible performance impact on typical transactions on modern servers, on these multi-core servers. There is, of course, some impact to it, but not as much as you might think, and we're going to compare that to another method a little bit later on. But just note that it has a very small impact that way. Of course, it also prevents the database from being attached to an unauthorized instance of SQL Server. So when you have an encrypted database, if someone is able to get hold of those files, they can't just go attach those to another database. So that's another protection you get there. It protects your data when it's on backup media without having to worry about encrypting the backups. And also it provides some level of protection against non-database administrators. So for instance, network admins, domain admins, other types of Windows admins that may have access to the file system but not have access to the database are going to be able to are not going to be able to get to the actual data contained therein, because while it's, again, at rest, it's encrypted. One of the other interesting use cases for TDE is protecting databases that may be synchronized from laptops or offline desktops or situations like that. Having the ability to encrypt those remote databases is also very useful and something to consider. Developers can use TDE as a means of protecting intellectual property, including proprietary business processes, and because it essentially is protecting the schema of the database. Even if they have access to everything else, they can't really see the structure of the database. Of course, there are areas where that structure might leak. For instance, if they have rights to the database, Crystal could be an easy method by which information could be leaked if you don't set it up properly. So there's some amount of setup required to make this secure. And of course, it can be used to encrypt databases that are distributed via sneakernet, CD, other means. So now we're going to actually get into showing you how to set up TDE, and we're going to show you how to use this on Oracle and Microsoft SQL Server. We'll talk about why we chose those two a little bit later. The first database we're going to look at is Oracle, and Oracle is a little bit of a beast the way it works here. Essentially, Oracle has something called a wallet that contains a Keystore, and that Keystore contains a master encryption key that's used to encrypt a table space. Users have access to that table space, and tables get moved into that table space. It's quite a bit to it here, but we're going to kind of walk through the process and do it a step at a time. So let's switch over here. And this is a just a sample machine that I've got here. We've already got some data in this Oracle instance on this machine. It's running Oracle 12c, the latest patch version of Oracle 12c. So the first thing that we need to do is we need to come into this admin folder that's related to the actual database instance I have set up, and we need to create a folder. The process for Oracle is a little bit more manual than it is for Microsoft SQL Server, as you'll see when we get to that. So we're going to create a folder called Wallet. Then we have to tell our Oracle server about this. And we use a property in the SQLnet.ora file that's under the network admin area of the actual database system. We use a setting called encryption wallet location. And the way we set this up looks a little bit funky, as you'll see as I paste it in here. That is not it. Here we go. So, encryption wallet location. You can see there's a bit to this. The reason the wallet location has so much to it here, that we're doing a file method, method data, all of this, Oracle actually supports hardware-based key stores. Now in this case we're using a software-based key store. And so essentially we have to tell it that this is, that our wallet location is for a software-based key store, and that's what all the rest of this stuff is in here, rather than just giving the path to the folder that we just created, which is this piece over here. So there's a little bit more to it that way due to Oracle supporting hardware-based key stores. I do not know what a hardware-based key store looks like, but it is an option that's available for larger enterprise setups. So we go through that process, save that. Next thing we need to do is run SQL Plus as the DBA. And we're going to set up a key store first. So setting up a key store looks like this. So we're creating a key store, we're telling it it's going into that wallet location, and then we're setting a password, which you would normally do something much better than this very simple password, but that's what we're going to use. Next, we need to open this key store so that we can do some other work on it. So creating it doesn't open it. So now we've opened our key store. The next step in the process with Oracle is to create a master encryption key. And this master encryption key is going to be used across multiple databases, even if we have them. In our case, we only have one database. And there is the possibility of setting up multiple master encryption keys if you want. And of course, one of the options that I'm going to use in here involves backing up the encryption key. So I'm telling it to create a backup of it here. And if we were to go look in our wallet folder now, you can see it's created this key store that contains a master key, and I now have a backup of it as well. The next thing that we're going to do is we're going to create a table space, an encrypted table space to store encrypted tables. Now, this is where we get into a little bit of a difference between the way the different environments work. In Oracle, your tables, if you're not familiar with Oracle, are stored in table spaces, and the transparent data encryption or whole database encryption isn't truly whole database encryption. You can pick and choose which tables you want to be part of it by putting them into an encrypted table space. So we're going to create one here. Basically, we're telling it where we want to store our encrypted file, and I just called it encrypt_df.dbf and set some default values on the size, that sort of thing, if you're familiar with table space creation. About the only really special thing I'm doing here is telling it that it's encrypted here using AES 256, and telling it that it's using encrypted storage as well. Okay, so now we have a table space. We're going to do a couple more steps. That's basically all that's required to get encryption set up. Now we're going to go about the process of actually putting something into our encrypted table space. So I'm going to alter one of my user accounts to have a quota in that encrypted table space. And then I'm going to issue an alter table command on one of the tables. I have the order entry example in Oracle right now. And so what we're going to do is we're going to go about moving the customer table and just the customer table into this encrypted table space. So that did it. That moved the customer table into the encrypted table space. If your tables were larger, of course, this could be a quite lengthy process that you have to go through. But in our case, with customer table, it only contains 1,500 rows or so, so it's a fairly quick process to go through. There is one other thing we need to do, though. When you move a table this way, it essentially invalidates the indexes because the indexes are kind of still stuck in the old table space. And we need them to be recreated in our encrypted table space. So I'm going to issue commands to rebuild all of the indexes. So very simple commands. I just went through and I had saved copies of the names of all the indexes off, and I run this alter index on it. So that's the process. We now have an encrypted customer table. How do we know that it's encrypted? Well, let's exit out of here. Right off the bat, if we were to go take a look at the prior table space, which was called users01, I've installed grep on my machine here. If I were to go look for, the string America, you'll notice that it was able to find it in that file without any problem. If I were to look for this same string in my encrypt df, you'll notice that I don't find it at all. And in fact, we can go in to our Dataflex application here. And of course, this would work the same if you're using Btrieve or any other environment, if your Magic application, VB6, .NET based, whatever the case may be. So I'm going to log in here and just show you one other thing. So we're going to come in here and we're going to create a new customer. And we will save this. Okay, so if I were to go look for that in our existing table space, if I go to look for Mertech data, you'll see it doesn't find it. And in fact, it won't find that same string in our encrypted table space either, because we are encrypted. But you probably noticed that I moved customer. If I were to go pull this out and page through some records here, you can see here's one that contains the string America in it right there. You'll notice that I moved my customer table over to the encrypted table space, but I can still actually see the data in the old table space. This is one of the areas that Oracle has a little bit of a more difficult process, and you can actually see this by way of the fact that I mentioned that there were 12 steps, but we didn't actually go through 12 steps. So if I go take a look at our 12 steps here, you'll notice we got up to step 9 of rebuilding the indexes, and we didn't do right off the bat, we only did one table, but we also didn't drop our unencrypted table space. So in our case, we only moved one table there, and I don't want to get rid of everything else that's in there. So that's the primary reason I didn't drop it. But essentially the process that you want to go through with Oracle if you're going to encrypt everything is you want to move all of your tables into encrypted table spaces and then drop your unencrypted table spaces and then use file system-based secure cleanup tools to make sure that you leave nothing behind. So Cypher is one that you can use if you were on a Linux-based system. They have things like Shred that you could use to clean up after yourself there. Essentially, Oracle's process has a data leakage issue from the standpoint of moving data into encrypted table spaces. If you started with encrypted table spaces, you have no problem. But it is something to be aware of there with Oracle. So now we're going to demo Microsoft's process, and their process is way, way, way easier. Essentially, we go through a four-step process. First, we create a master key, and this encrypts the master database. And this is something to note with Microsoft. If you use encryption at all, your master database is always encrypted. This master key that we're going to create gets encrypted by the service master key, which is something that's created at the time that you install Microsoft SQL Server. Then we will go about the process of creating a certificate that will be used to encrypt the database encryption key that we're going to create as the next step. And then at that point, we're going to do a simple alter database to turn on encryption. So let's go through this process. So we can get out of here, and we will close this. And so that we can show you what this looks like, I'm going to do a couple of quick changes here. So I'm going to log into our SQL server and just change out, remove the driver prefix and add it back. So now we're linked to our Microsoft database, and we actually need to close the DataFlex Studio entirely. And then we've got to go over into our order entry and move all of the end files. Okay, so now we're running against the SQL version. Looks like I actually crashed the studio here, so let's go ahead and close this. Okay. There we go, and you can see it's trying to connect on here now. Go ahead and connect. Okay, so now let's go about the process of converting our database for order entry and encrypting this. So I have one script that does the whole thing for me here. I'm going to copy this in and kind of go over it with you briefly here. Okay, so essentially we're just going through that same process I described, creating the master key, creating the certificate, creating a database encryption key for our order entry database that's encrypted by that certificate, and then altering the database and turning on encryption. So if all goes well, oh, there we go.
Oliver, I have a question from Roll. Which version of SQL Server are you using for this?
So I'm using SQL 2016 right now. This is not a feature that is limited to 2016. I think it goes back at least to 2005. The reason I'm using 2016 in this case is because we are going to be showing some features that are 2016 specific in a little while. So, and this is, I believe I'm on 2016 release candidate 2. You can kind of see this down here at the bottom here. Localhost 13.0 is the version number. That's like the internal version number that SQL uses.
And is there a SQL Express version, a free version of this?
There is not a SQL Express version of transparent data encryption. In fact, we'll kind of go over that a little bit later, but transparent data encryption for SQL is only provided in the Enterprise Edition. So we're going to be talking about some other options for you in a little bit more detail later on. The same thing goes for Oracle, by the way. I was using the Oracle 12c Enterprise Edition there. So I ran this script. It gave me a warning letting me know that I haven't backed up my key and that I should probably do that. And that is a good idea. I don't have that in here right now. But that's essentially it. We're using an encrypted database now. And from the application standpoint, nothing has changed. It has no clue that we've done anything there at all. It just knows nothing of it. It's completely transparent to the application. Nothing special is needed to set it up. I was going to show you, like I did with Oracle, where I actually check the contents of the file, but that's actually a really difficult process with Microsoft SQL Server to go in and check to make sure that your data is actually encrypted. The reason that's the case is when Microsoft sees an encrypted database, they change rights on the file as well. They figure that you're trying to prevent users from getting to it, so they change all of the rights on the table, or excuse me, on the actual MDF files, MDB files, and LDF, and make it very difficult to access those files directly. So I'm not going to go through that process, but I now have an encrypted database for my Microsoft SQL Server. So that's essentially it. That's transparent data encryption for Oracle and Microsoft SQL Server. It's a pretty simple process. So the question remains, what about everything else? Transparent data encryption is only part of the solution. There are three other areas that most people talk about and that really affect how you use this and that fit into your business processes. These other areas are column level encryption, line level encryption, and data protection. The first area that we're going to talk about is column level encryption. And we're actually going to talk about why I hate column level encryption. So when we talk about column level encryption, there are a couple of different solutions out there. We'll go over some of the different solutions a little bit later on, but right off the bat, it's slow. It's slower than transparent data encryption. This is really counterintuitive, but the reason that column-based encryption is slower is because of the fact that it limits the database engine's ability to optimize your queries. Transparent data encryption doesn't have this limitation because it's essentially encrypting and decrypting pages of data as they're read from and written to the disk. So even from the standpoint of the database, it's not touching the query engine in any way, whereas column level encryption is severely affecting the query engine's ability to optimize your queries. And in fact, there are very severe limitations on indexing encrypted columns. We'll talk about that in just a moment here, but it's something to be aware of. Also, when users put in place column level encryption, it tends to be leaky. So I talked about data leakage from the standpoint of Oracle just not cleaning up after itself when you use their TDE. What I'm talking about here is a little bit different. So I'm going to give you just a simple example. Let's say you have a database that happens to contain PII that involves a person's date of birth, maybe it involves their current address, and maybe you even have their social security number. Now, what a lot of people do is they'll go, okay, well, I need to encrypt this column that contains their social security number, but I want to show the user, or I only want to encrypt the first 5 digits. I want to show the user the last 4 so that they can verify they're talking to the right person. It's a very common scenario. There's a big data leakage risk associated with that, though, and I'm just going to kind of walk you through the process. And some of this is based on knowledge of social security numbers directly, but this happens with all other types of data. So this is just an example, but we see it all of the time. So if I know the last 4 digits of someone's social security number, how hard is it to find the first 5 digits? How good is the column level encryption? Well, the first thing I would do if I were going about this process is I'd come over to this site, Social Security Numerology, and this is very US specific here. But basically Social Security numbers are handed out in a very specific fashion. They're state-based. A lot of people may not know this, but they're very state-based. So if I know that someone is currently living in the state of Maine, there's a high likelihood, nationwide about a 60% chance, that they were actually born in that state as well. In the state of Maine, we have simply 4 prefixes on a social security number. So now I've limited the first 5 digits down to a very small subset of these 4 prefixes. Now within each one of these prefixes, I can take a look at the valid numbers that have been issued within that prefix, and I can look at the approximate date that those were issued from originally. So if we go all the way back to 00401, those numbers were issued back in the 1930s. So if they're a younger person, it's very likely that they will have a number down in this range here. So this gives me a very limited list of possible options for the first 5 digits of their social security number. But if I wanted to make sure I really got it right, I would then take that very small list and come over to this site and put in that list to verify whether I've got an exact match. There are lots of logins for this that people have published online so that you can get in and it's completely anonymous for you, and you could see someone's verify that you did get their social security number right. Now imagine automating this process on a large scale. That's a form of information leakage that encryption does not fix. Nothing is going to fix that form of data leakage. But a lot of people use column level encryption to attempt to fix that. Additionally, column level encryption has lots of complexities associated with it that can result in data leakage as well. For instance, when you're using this type of encryption, you have to worry about the mode of encryption. You have to worry about whether you're going to include a MAC, message authentication code, whether you're going to salt or not salt the encrypted data, whether you're using deterministic or non-deterministic algorithms, and many other very technical topics that only relate to column level encryption. Each case that you use it in is different than the last too. So no 2 cases that I've seen with this are the same. And there's really a risk of poorly configured column level encryption causing data leakage or the equivalent of no encryption at all, even in many cases. Also, this is what I like to call a unitasker, to borrow a term from Alton Brown. Its only purpose that actually makes any sense at all is to protect data from people that you should trust, and it doesn't even do that well. The only reason that people tend to use column level encryption that really makes sense is to do something called blinding your DBA, which is a form of separation of duties. The idea is that by moving the encryption process away from the database server, the DBA can only see the encrypted data, but it rarely works out that way. That's the concept behind it. We rarely see that work. For instance, with Oracle, it doesn't work that way at all because Oracle provides transparent column encryption as well, and the DBA would have access to all of the unencrypted data. So something to be aware of. Microsoft thinks they've solved this problem, and we're going to talk about their solution a little bit later. So column level encryption is not something I'm a big fan of, as you can see. But there is some uses for it. We're going to give you some alternatives right at the end. Next up is line level encryption. This is basically the piece that a lot of people forget about, and it's very often neglected. But just because you have remote sites that access your data over a VPN and that VPN traffic is encrypted, that has nothing to do with what's going on inside your network. All major database vendors support line level encryption. I don't have a huge amount to say about this other than the fact that you should be using it. It requires a little bit of work with certificates to get set up, but it's pretty straightforward. Wi-Fi is, of course, even more overlooked in this area. If you're not using line level encryption and you have your data over Wi-Fi, you may be dependent upon the encryption provided by Wi-Fi to protect your data. But don't think for a minute that WPA2 provides enough encryption to make this a moot point. Security is very much so like an onion, and this is just another layer of it that you do need to deal with. So it's not difficult to set up, and from the standpoint of support, we'll show you who supports what related to line level encryption in a few minutes. The last pillar that we have to deal with here is data protection. Data protection goes by many names. Microsoft SQL Server calls it dynamic data masking. In Oracle, it's called redaction. In PostgreSQL and MySQL, it's called non-existent. They don't actually have anything for this. This is a really cool feature, and it's basically the piece of the puzzle that I actually like the most. I think this is a really neat technology. The idea behind it is to give a specific property, to set a specific property on a column in your table that causes that column to return a masked or obfuscated version of the data, unless the user requesting the data has a certain privilege. If they have this privilege, the data is returned unmasked all of the time. The reason I like this feature so much is that it just works. You don't have to code anything in your application to make it work. It works with reporting tools. It's really neat. We're going to show it to you. So it's time to get into a demo here for this. So we're going to again use our order entry example. We're going to demo this feature in Microsoft SQL Server on our customer table specifically. And what we're going to do is we're going to mask our phone number column. So if we were to go look at our table structure here and look at the phone number column, there's nothing related to masking in here. The reason we see nothing about this masking technology in the properties for that column is that this is a brand new technology for Microsoft SQL Server 2016. That doesn't mean that there's no other way of doing it, but as a built-in feature, it's brand new to SQL 2016, and I think it only came in even at this specific release candidate or the prior one. So it's a very new technology for Microsoft. On the Oracle side of things, it's actually been around for I think since 2014. So that means we have to use manual SQL to turn this on. So this is the SQL we're going to use to do this. So we're going to alter the customer table. We're going to alter the phone number to add a mask. Now this mask is a function that's completely transparent to the user. And there are different functions, masking functions that you can use. In this case we're using one called partial. There's a much simpler one called default. But I think the partial one is a lot more interesting to look at. And it takes 3 parameters. The first parameter is the number of characters from the column that you want included in the data. The second parameter is what you want to pad in the middle of the data. And the last parameter is the number of characters from the end of the data that you want to include. So in my case, I'm doing a phone number. I'm including the first 3 characters, which would be the area code. I'm masking out everything else and including nothing from the end. So let's go ahead and execute that. Select text. There we go. So we've executed that. What did it do? Well, if we were to just go in and take a look at our application and page through records, it didn't do anything in this case. The reason it did nothing here is because I am running as a highly privileged user right now in the order entry example. So let's close out our program here, and we're going to restart it, and we're going to, instead of logging in as my trusted connection, we're going to log in as a user test that has a more limited set of privileges in the database. We're going to come into our customer entry view and now look at the phone number field. phone number field has been masked out here based on that masked data and the fact that this user does not have the privileges to see the rest of the data. You could imagine this being used on, for instance, a social security number, even though I mentioned maybe that's not the best idea. You could mask out some characters from the social security number very easily without needing encryption at this point. We're using just system rights to control this. Now let's take a look at, actually I can go right back in here. I have a Flex to Crystal report that I've set up in here using Crystal 2013 for Visual Studio. I created a very simple report. Just to show you, in this case I'm running the report again as that trusted user, and you can see that I get all of the data back. If I were to go into my actual Crystal report here and basically change the authentication data for the report at runtime, basically the real important piece here is turning off integrated security and then setting a username and password that's that limited account. So if I go run this report, and you'll see here that it follows through everywhere in the system. It doesn't matter if it's Crystal accessing it using its driver, using the native ODBC, or if it's Dataflex accessing it, or Btrieve accessing it via our drivers. That form of data masking is returned in any case based on the privileges of that user. And so essentially I didn't give that user the unmasked privilege, and it allowed me to do this. Very cool feature, works in a very similar fashion in Oracle using something they call redaction. In many cases, this is actually what people are wanting to do rather than encrypting data. They're wanting to prevent users from accessing it. I'm going to show you one more thing in relation to this real quick. So if I pull up this data here, the things you'll see, I've got a phone number entered in here. I'm going to go in and I'm going to change the phone number and save the record. And then I'll pull it back up. You'll notice that my change was saved. Data masking doesn't have to do with whether I have the ability to update that column. That's a different right that, of course, most of the database, all of the database servers have the ability to set, whether I can alter that column. This can actually be really useful in the case of verification of various numbers. You may allow someone to, for instance, enter a credit card number, but then if you're storing that credit card data, you may want to mask the data out if they're looking at the data and only give them a partial view or no view of the data to verify it with a customer. It doesn't remove the ability to do anything with it. It's just masking what's returned, and it masks it every way you could access it, whether it's a SQL view or anything else like that. Pretty cool feature.
Oliver, a question. Is this available in SQL Express for 2016?
So that's what we're going to go into right now. Who offers what? This is a pretty complex matrix of what we can find offered in various areas. To answer that specific question, the answer is we don't know yet. Microsoft has not said where the data masking feature is going. We don't know if it's going to be an enterprise-only feature or if it's offered all the way down to Express. Literally, it has not been announced yet. SQL 2016 is not a released product. As you can see, I was on RC2 of it. So this is, for Microsoft, the absolute bleeding edge. From the standpoint of Oracle, this is a feature that you only get with their Enterprise Edition, and you have to purchase their advanced security option on top of Enterprise Edition to get it. If you'll notice, Oracle supports almost everything. They support column-based encryption that is transparent. They support this redaction and have since 2014. They support SSL line level encryption, but all of it requires a high edition of Oracle. So something to be aware of there with Oracle. It certainly isn't the cheapest option out there. Microsoft, PostgreSQL, and MySQL are a little bit more advanced from the standpoint of their offerings. So this TDE that I showed, like I mentioned, has been around since about 2005 and is part of the Enterprise Edition. But there is a third party, and I'll show you their site, Netlib, that offers a product called Encryptionizer for SQL Server that gives you transparent data encryption and transparent column encryption on older versions of SQL Server. And these are for versions of SQL Server from Express all the way up to Enterprise. I don't know why you would want to use their stuff on Enterprise if you already have an Enterprise license. But that is a third-party offering to provide TDE without having to purchase the Enterprise Edition of Microsoft SQL Server. Now, Microsoft for SQL 2016 also has a new system called Always Encrypted, and that's something I wanted to just briefly mention here. Always Encrypted is Microsoft's transparent column encryption solution that basically is a little bit different than Oracle's in that the encryption-decryption process is handled at the client using a new secure ADO.NET library rather than being handled at the server, so that you get a little bit more of that separation of duties. It blinds the DBA. So there's Microsoft's selling point on this is that it enables delegation of on-premise database administration to third parties and allows you to reduce security clearance requirements for your own DBA staff. So that's a brand new feature. Of course, Encryptionizer provides that. Now, from the standpoint of this data protection, Microsoft's solution is, again, brand new, but there is another third party out there, a company called Hexateer, that provides a whole bunch of other services, including data masking. They have this unified database security system that provides dynamic data masking, and they provide this for Microsoft SQL Server. You can see I mention it here, and they also provide it for MySQL. So Hexateer is doing some pretty neat stuff with that. From the standpoint of line level encryption, all editions of Microsoft SQL Server that support networking, so everything except local DB and their and kind of their pocket database stuff, support SSL. So you get that for free with Microsoft all the way down. That's why I advise everyone use that. If you're on Microsoft SQL Server, it's included free. Now, when we jump over to MySQL and Postgres, of course, they both get OpenSSL included right out of the box. But you can see the offerings are a little bit more mixed. For PostgreSQL, they have no transparent data encryption solution, and they advise you to encrypt the disk or the partition that your database is on. Which a lot of times can meet regulatory requirements. There are some iffy spots in there. For column-based encryption, they are using something called function-based, and you'll notice MS-SQL's solution before 2016 built in was function-based as well. And just an idea, a function-based encryption looks something like this right in here. Essentially, when we do our insert or our select statement, we actually have to define a function around the data and tell it to encrypt it or decrypt it on each individual SQL statement. So it makes it hard to integrate with your application. It does require application changes. From the standpoint of data protection, for PostgreSQL, you'll notice I've got a question mark next to rules. PostgreSQL actually contains a very powerful rules-based engine that can be used to do basically runtime analysis of SQL statements and modification of those SQL statements. So for instance, you could put in a rule in the rule engine that changes select statements that involve a certain column and table to automatically wrap that column in a encryption or decryption function based on whether it's a select or update statement or insert statement. So that's not something that is any sort of built-in support. It would be a roll-your-own support system entirely in that area. MySQL, on the other hand, has, again, this hexatier product available for it. And Encryptionizer is also available for MySQL. So you have TDE-based options from a third party for MySQL that make it real easy to do this. So, like I said, pretty complex table here as to what the options are depending on what backend you're using. Certainly this is something that we're going to put up on our blog. And as I mentioned, a lot of these features are brand new. One thing to also note on Oracle, their redaction feature has had a lot of exploits available for it. It looks like they've fixed most of them recently, but one specific individual, a guy named David Litchfield, has basically broken open the redaction feature in Oracle multiple times. So if you are using this or planning on using it, you want to make sure you're using the most patched version available from Oracle. So what do you do? What do you use for your specific environment? Well, I tried to make a table here. I don't know how helpful it'll be for all of you, but you know, if you're dealing with regulatory requirements, really your options that look the best from my standpoint are using TDE or whole database encryption, along with these new data protection masking features and line level encryption. If you have the need to limit user access to personally identifiable information, data protection is a good choice. Whole database encryption can also be good there. And if you're looking at limiting data leakage, these are also your choices. One thing you'll notice in this table, though, is this column. The only thing that handles separation of duties that I mentioned here is column level encryption, and as I said before, I am not a big fan of column level encryption. So are there any other options available for this? There are. Effectively handling separation of duties is something that many companies have taken on. They're choosing to avoid column level encryption entirely and solve two other problems at once by using database firewalls and database activity monitoring. The idea here is to put something in between the database access layer and the user. A database firewall can use advanced SQL grammar analysis to block queries, while monitoring tools will report on queries. So it basically is a layer that sits over the top of your database server from the standpoint of both of these, monitoring and firewall tools. And they make it harder for the DBA, the person that you're trying to get that separation of duties with, to access the data entirely from the standpoint of a database firewall, or if they do access that data, to be able to report on it. The additional benefit that you gain with these monitoring tools is compliance reporting. So a lot of the regulatory bodies for PCI compliance, for SOX compliance, require audits, and these tools provide that. The one special thing I want to mention here is Oracle Audit Vault and Oracle Database Firewall. Both of these products actually will sit over the top of Microsoft SQL Server and over, I believe, and MySQL in addition to Oracle, so they're not an Oracle limited product. This idea of using database firewall and monitoring to basically track what your DBA is doing ends up being a lot cleaner solution, in my opinion, than using column level encryption. Using these two additional facilities, I really don't see where in most environments column level encryption is going to be the right solution. There may be some corner cases where you need to use it, but these tools really provide what you're looking for from that standpoint. So essentially, that's database encryption in a nutshell. As you can see, there's a lot to this topic. So I want to open it up, see if anyone has any questions. I'd be happy to answer questions on any of this stuff that we've gone over, or anything that maybe I didn't go over clearly enough.
So I have a question from Roel again. Is the NetLib solution cost-effective in comparison with SQL Enterprise?
I don't have cost information from NetLib. Their entire business model is getting people to not buy enterprise in most cases and to buy their product instead, and it's not providing hardly anything that enterprise doesn't provide, so I would be very surprised if it did cost more than an enterprise license. They're trying to sell to these smaller shops. In fact, they even have solutions for providing encryption in your application elsewhere. They have these products for desktops as well to provide encryption for access and other local databases. So you know, they're meant to be a lower cost solution than enterprise software for it.
So Oliver, one question, you're saying that you're against column level encryption, but in the absence of this dynamic masking in most of the products currently available, you know, and applications all have user ID and password-based access, what if I wanted to hide the data in a specific column coming from the database in a view in an application? How would that be handled otherwise?
So there isn't great ways of handling this. You can there are some solutions that people have put up online for attempting to mask data using some other methods, including SQL views, for instance. The problem with most of those methods is that they're not secure, and so if you're having to deal with anything where you need to know that you're using enterprise-grade secure methods of doing things, none of these other solutions work very well, and so column level encryption can be useful there. Like I mentioned, it is a brand new feature for some of these vendors, but really it's the right solution. So it may be very new, but I think in the next 12 to 18 months it's going to be what everyone switches to using. So if you can avoid having to use the column level encryption now and can wait for this data masking technology, I think you'll be in much better shape.
But the column level encryption is available in different versions of different editions of the database, correct? With SQL as well as...
It is available in all databases, all versions, essentially, at a functional level. Even though Oracle mentions their column encryption as being enterprise only, there is the ability to do function-based encryption with them as well, like you can with the other database vendors. It just requires a lot more change to your application and planning on your part.
Okay. All right. So we are running a little bit over. Are there any more questions from anyone that we could field? Well, we are always available by email, and Oliver has his email up there. You can just contact us if you have more questions regarding database security. Thank you all for attending today, and we'll be coming back soon with another in this Campfire series. Thanks.